Sow 151. Oh, this Hangout's on air. Hello, everybody.
We're talking about rum.
Yeah, we very much like rum, but this is about Git. Now, I can't see myself. Turn camera off. Okay, I think everything is on. Let's do a bit of a screen share. Just do the entire screen. Great. Apologies for running 5 minutes late. People that are watching, ooh, that's trippy. Trippy. Great. Git. No, really. Git. Yeah, you can do it. You present. Definitely going to edit this bit out. And now I get to do a hard reset that I can completely cut. Hi, everybody. Thanks for coming. Sorry. Okay, great. So this is a beginner's guide to Git. So that's me. You probably all met me by now. I can probably start deleting this slide from all of the things that I do here. So what is Git? So how many of you in the room are programmers or have to use source control? Great. So a good majority of you will have to interact with this at some point. So Git is a naughty word. It's an open source, cross-platform, distributed version control system. And
sorry.
It's okay. So it's a kind of source control management system, and it's awesome. So Git exists because Linus Torvalds hates Subversion. That's an actual photo of him talking about Subversion. So Linus is a very, very opinionated gentleman. Pause. Definitely a gentleman. And he's famous for writing Linux. But actually, it sort of exists because he hates Subversion. It more or less exists because he needed a source control management piece of software to manage the Linux kernel. So the Linux kernel is about 25 years old, probably more now, actually. It runs about half to 60, 70% of the computers in the world. It's very, very large, very complex. Most interestingly, it was developed and maintained by contributors in a very decentralized manner. So in about 2005, there was a lot of drama because from 2001 to 2005, Linus used a piece of software called BitKeeper to source control Linux and the core Linux kernel. And there was a very, very big falling out between Bitcommit, the authors of BitKeeper, and open source, because one of the guys that wrote the original version of Samba and contributed a lot to Linux reverse engineered their on-the-wire protocol, and the company got very, very angry with them and revoked their open source license. So when you have a massive, important open source project and all of a sudden the people that you are using for source control tell you can't use their software anymore, you have to kind of start looking at alternatives. So a lot of people at the time were saying, oh, well, Subversion's this great new cool thing. It's CVS done right. It should definitely work. And there's all sorts of threads all over the internet where people were pestering Linus about migrating to Subversion because Bitcommit were evil. But actually, Linus was a big fan of BitKeeper. And if you go back through the threads on the internet at the time, he's very, very complimentary about them, because effectively he got dragged into this whole problem by somebody else working on another piece of software, reverse engineering something. And he actually had a falling out with the guy that did that in the process. So Linus was a big fan of BitKeeper and another source control management piece of software called Monotone. So what he did was he looked at the design of those pieces of software, and he didn't want to necessarily clone BitKeeper, but he wanted to build something that was suitable for Linux kernel developers. So he was very, very flattering about other source control management solutions at the time. So this is a direct quote. I credit CVS in a very, very negative way, because in many ways, when I design Git, it's a what would Jesus do, except that it's what would CVS never ever do kind of approach to source control management. When I say I hate CVS with a passion, I have to also say that if there's any Subversion users in the audience, you might want to leave, because my hatred for CVS has meant that I see Subversion as being the most pointless project ever started. There is no way to do CVS right. And at the time, Subversion used to have the strapline, CVS done right. So that was a conference in front of about 1,000 Google engineers. So yes, Linus, massive fan of Subversion CVS server. You can watch it yourself. It's actually a really entertaining video. I mean, Linus is awesome. He's a great public speaker. He's self-described as a bit of an opinionated asshole. That's what makes him entertaining, but it's also what leads to some really good innovation. So what does Git mean? So honestly, this is the official reason that Git is called Git, because Linus is an egotistical bastard and he names all his projects after himself, and he's a bit of a Git. Some trivia for you. Enough about history. So Git is distributed version control. So does everybody know what version control means in the room? Great. So if you're coming from TFS, I pity you, Subversion or CVS, the first thing you'll notice is that Git is decentralized. So I'm going to go into what exactly that means. So in centralized version control systems, when you get latest, there's a server somewhere with all your source code, and you pull the latest version of the software. What you actually get is the exact latest copies of files that were checked into the source control system. No history, nothing. You just get the last snapshot. In Git, you get everything. So a centralized workflow looks something like that. There's a shared repository which might have access control rights around it, and it has all the code, the history, and all the commit logs. And a developer can push and pull between the central repository. So in traditional terms, that'd be checking in and checking out code. Some, albeit less desirable source control systems, feature exclusive checkout rights. So you could actually get into a place where you want to work on a file, you check it out, and nobody else can touch that file until you're done. And that means that all your work serializes behind it, and it's just a nightmare. And over the last 15, 20 years, I think people have come around to the opinion that's not a very good way to work. But people like command and control love that kind of stuff. So traditional version control systems are server controlled, and when you check out, you only get the latest version of all the files. What this means is you only get the good stuff about source control when you're connected to the server. So if you're on a plane or on a train or at home and want to see why the file on your laptop has a certain change in it, well, you've got to wait till you turn up to the office the next day, the next week, the next month. You can't really work disconnected, and it's a bit of a painful experience if you ever try. So Git had to support kernel developers, and that's why the origins are really important. So the design goals of Git were for speed, simple design. I think simple being a very, very subjective term is probably debatable when I get to the second half of this presentation, talk to you about how Git actually works on the command line. Strong support for non-linear development. So the Linux kernel before 2001 solely was maintained by people sending patch files of change deltas via email and mailing lists. So that decentralized workflow was very, very important to them, and BitKeeper supported that directly. It needed to be fully distributed because Linux wasn't really an organization. And it needs to be able to handle massive, massive, massive multi-year, multi-decade projects. So distributed design for source control looks something more like that. So these are from the official Git manual pages on the web. So the cool thing about decentralized version control is anything goes. There's no real sense of a master repository. There's just the copy of the code you have. And you can do anything to it, and you can swap those changes with anybody else that has a copy of the repository. And that's really, really powerful because it means you can bend and build your own workflows. And that's exactly what this slide says. Those kinds of workflows were important for kernel development especially. So because of this design, Git works very, very well for distributed teams, but also you can use it like you would a centralized version control system. So you can still have a Git server with your master Git repository that people send code changes to. The mechanisms in which you send code changes are slightly different. So gone are the concepts of exclusive checkouts and locking of files, but you can still have a big single source of truth. The additional benefits, though, are everybody that interacts with that repository also has a complete copy of history. So depending on your perception of that, I think initially, say 5 or 6 years ago, a lot of organizations thought that that was a bad thing because, oh my God, my developers can leave with all my code. But they were just practicing security theater, really, because even with a centralized version control system, the developers could take the latest copy of code and walk out the door with it. There was no real security there. It was just paranoia. So interestingly, Git is now the most popular source control in the world. And that graph is astonishing from 2009, and that only goes to 2012. So there's nothing else that has competed in the last 3 or 4 years. That line has just kept on going up, especially with the popularity of mostly free online source control providers like GitHub, like Bitbucket. Even Microsoft's TFS now hosts Git, TFS Online. And the thing about source control is people learn the cool one because that's where all the good code is. So if all of the most interesting things you want to work and contribute with are in Git, people will go to Git. And obviously the Linux kernel set the precedent for that by being quite big, quite popular, and quite important. Apparently I'm going to a gig. So the real key benefits of migrating to Git revolve around being able to commit whatever, whenever you like. So because you have a full clone of the repository, you can tear your own repository to pieces, you can delete stuff, you can go mad, and you can know that it'll affect nobody until you share that code. So you can do some things that maybe were previously seen as sketchy, difficult, scary maneuvers in source code, and the worst thing that can happen is you just don't share them. So that kind of spirit of experimentation is really empowered by source control that works for you rather than against you. Cheap branching and merging. So this is something that if you've come from a traditional centralized source control world will seem crazy, because in Subversion, a branch is a copy of every single thing. It's this massive deep tree, and merging a massive deep tree back in is a nightmare. Anyone that's merged any kind of long-running Subversion branch will know that they never ever want to do it again in their entire life. Miserable experience. In Git, as I'll go into later, a branch is just a hash, and I'll explain exactly what a hash is in Git in a few slides' time. So flexible workflows, we've covered this, but if you want all your code to come through as a guy who sits in an office in another country, you can make sure that everybody sends him pull requests and then he vets the code and sends it to you. You couldn't do that in a centralized world. If you just want everybody to be able to commit to a centralized repository, you can do that. If you want all the people that clone your repository to share changes between them before they give you changes, you can do that too. There are literally no rules as to who and what can be sourced from where. Repositories are fully replicated. So previously, if your centralized server got deleted or exploded or set on fire, if you haven't backed it up, you just lost everything. Well done. With Git, no problem. Just go to the developer who has the most recent copy of the repository and push it back up. You can't really lose your code. I mean, the downside or the side effect is your code is literally everywhere. But actually, you never need to back up a Git repository really of anything that's sufficiently well used. Coming from other source control providers, there's less noise on the disk. So especially compared to Subversion, I mean, Linus really, really hated Subversion. Can't stress that hard enough. So Subversion puts little directories in every single node in your folder structure called .svn, where it stores metadata. But what it means is if you actually look at your project on the disk, it's littered with all this junk, just junk that isn't your project everywhere. So Git has one hidden folder that's stored at the very, very top level that contains everything, the full history of everything. You don't see it anywhere else. And it performs incredibly well. So traditionally, if you're using Windows, it used to perform very badly, but over the last 5 or 6 years, a lot of work has gone into making it work very, very well and make the tooling excellent. So I suppose the interesting thing about Git and performance is that Git is secretly a file system. So Linus isn't really a source control guy. What he writes are operating systems. So what he wrote was a compressed file system of versioning history that just so happened to be packageable up in a directory that you could zip up in a tarball and send to other people. So there's a lot of things about Git that resemble file system design. We're probably not going to touch on any of that in a beginner's guide to Git, but it's kind of interesting. So there's going to be a lot of reading here, I'm afraid. So getting started, that's Octocat. It's nothing to do with Git necessarily. It's GitHub's mascot. It's super cute. Everybody loves Octocat. And I don't know why it's getting one out of a box. But. So I'm going to go through some basic Git terminology so you can understand what people mean when they say some things. I apologize if this is very, very obvious to you, but it's very important to be specific. So we're going to go through repositories, forking and cloning, commits and hashes, branching and merging, remotes and origins, pushing and pulling, and the staging area. So in Git, a repository is a folder with all your source code in it. It contains a compressed and packed down complete history of every commit ever made to the project and all of its settings and configuration. So things like settings for configuring how white space is preserved and line endings and your usernames and all that kind of stuff is stored in the secret hidden folder at the top level of your project called .git. A fork in Git is a complete copy of a repository that originates elsewhere. If I fork your repository, I then have a complete clone of your repository, including the entire history. Each commit you make in Git stores only the delta between the last state of your code and the next state. These commits are given an sh1 compressed hash. That's effectively the version number of a Git file. So a file or a change set has a hash associated with it. You're not going to remember a hash because it's about that long. So it's a GUID or a UUID, depending on your terminology. It's a massive long sh1-like hash that's globally unique. Secretly, everything in Git is actually just a hash. So branches in Git are very different from centralized version control. It's just a pointer to a commit hash. So a branch in Git is not a copy of all the files. It's a low-level pointer saying, at this point, I'm going to branch and I'm going to contain all these changes. So when you branch in Subversion, you might branch a big tree and it'll say, oh, wait 5 or 10 minutes while I copy everything. You branch in Git, it's milliseconds, 10 milliseconds, 15 milliseconds. It just makes a new pointer and switches your state. So branching and merging in Subversion, you may be familiar with the concept of trunk, where all your work goes. In Git, master is the equivalent to trunk. Your master branch is your main line. Remotes are the remote clones of repositories that you're currently working in. So if you forked a repository from a remote source, you can configure that source to be a remote to your local repository, and you can push and pull changes to a remote that you have permissions to push and pull to. By convention, origin is the place that you cloned your repository from originally. You can call it anything you want. You can add as many remotes as you like, and you can give them lots of names. So for example, you could clone down from a GitHub repository, and that would be your origin. But then Bob could clone down from the same repository. And then you could both push your repository somewhere else and add each other as remotes, and you could share code between you guys without ever pushing back up to the original source. So you can have as many remotes as you like, and you can do whatever you like with them, as long as you have permissions. So interestingly, Git doesn't map permissions at all. If you can see the repository, you can push and pull to it. What that means is third-party services and products wrap permissions around it. So for instance, GitHub uses SSH certificates or web-based usernames and passwords to authenticate permissions between you pushing and pulling to a repository. But Git itself, bare, doesn't have that concept. So pushing and pulling is when you synchronize with an upstream remote. So if I clone from a GitHub repository, that's my origin, that is my upstream, and I can push and pull changes between those two things. So pushing is obviously me sending my latest local commits to them, and pulling is me synchronizing state and getting my latest back. So in centralized version control, pulling is forced most of the time. You can't commit anything because when you check out, it automatically pulls the latest version of the code. So in Git, that's not the case. Two repositories can move in different directions, and unless you pull to synchronize, you won't see those changes. So when you pull, you merge the upstream changes into your local repository. And merging means the same thing as it does in every single source control provider ever, taking my changes from over there and putting them in this other thing. That's a push me, pull me. So the staging area, this is probably one of the most confusing concepts that people new to Git but having used other source control providers get. So Git has something called the staging area, often referred to as the index. So you do a two-phase commit with Git. If I'm making some changes, and we're going to demonstrate this later, so don't worry if you can't visualize it. If I'm making some changes to a file, I have to add those changes to the index, and then I commit my changes as a whole. The design philosophy behind it is that you can be working on a big tree of stuff and you want to add certain changes in, but maybe not some other changes. So you add the specific changes that you want to have be part of the commit, and you commit them with a message. So that's a two-step thing, whereas with something like Subversion, you check something out, and when you check it in, your changes go, and you check in per file. Whereas Git commits can contain multiple files, all under one SH1, all under one hash, that you stage and then commit. So let's run through some basic usage scenarios. So this is going to be a lot of reading from the command line. I apologize. Unfortunately, or fortunately, everything to do with Linux and Linux toolvalves is based around the command line. We'll talk about good tooling later. I say good. People on the internet who may be watching, maybe like sacrilege, don't talk about using graphical tooling with Git, but it's there, so don't panic. But it's better to understand the first principles to start off with. So can you all read that? Great. I can read it from here, sorry. Actually, ironically, can't read it on my screen, but I can read it on the monitor. So that's an empty directory. I was going to demo this live, but I figured screenshots were safer. That's an empty directory. There's nothing special about that. And that's a bash shell. So when you install Git on Windows, it'll install a whole load of stuff that gives you a bash command prompt in Windows. If you're on a Mac or on Linux, it's just there. Don't panic. You just got it. So all I've done is made an empty folder, and I've opened a command prompt. So if I want to start a new Git repository, I have to do nothing more than type git init. So you'll notice what happened there. If you look at the directory window on the right-hand side, is it created the .git shadow folder. So I have hidden files visible here, so I can see that. If you don't have that enabled in Windows, you'll never see the .git folder. So now I can start adding files to my index. So to add a file to the index, all I'm going to do is echo the word hello into a file called test.txt. So that's just a standard feature. You can echo file, you can pipe into anything. So you'll see I've got a file exists here. So all you have to do is type git add dot to add all changes since the last commit to the index. You can also, instead of saying git add dot, you can specify specific files that you want to add to the index. But generally, a lot of people will just work on a bunch of files and add them all together. So I actually have a Windows Explorer plugin there. So you'll notice it's gained a little plus symbol there that shows you that it's been added to the index but not committed. So from here, we want to commit it. So git commit. So now you get a taste for how annoying remembering the command line options are if you've never used Git before. So git commit -a -m and some message. And what that does is, if you notice on the screen, it's committed to the branch master, which you can see as the branch specification, both in the command prompt, and then where I have committed, it tells you that I've committed to master with the message equals added test file, because I completely typed equals every time. That was an accident. One file has been changed, one file has been inserted, and it's created a file. Great. So now we've got a file, and it's been added to the index, and then it's been committed. So that's the two-phase commit that I was describing. So now I can check the status. So you just type git status, and it'll tell you where you are and whether you've got any changes in that directory versus where the repository is at the time. So okay, we want to change something. So I'm going to echo hello again into that file. So I'm going to completely overwrite the file with some extra text. So now if I type git status, it'll tell me what branch I'm on, but it'll then also warn me that I have files in my repository that are not staged to commit. So it says, you've got some dirty files here that you've not added to me. What are you going to do about it? So simply I git add everything, and then I commit. And then it'll tell you, if you notice, it says one file has changed, one insertion and one deletion. So now if I call git status, it'll tell me that I'm on the master branch, I have nothing to commit, and my working directory is clean. So if I want to take a look at where I am, I was talking about how everything is a hash. If you type the wonderfully memorable git rev-parse capitalized head, it'll give you the hash of exactly where you are in the repository. So you're definitely not going to remember all these command line prompts from this at all. Don't worry. So there's a visual tool that represents exactly what I've done. So if you've ever used Subversion, you may be familiar with Tortoise SVN. So you can equally get Tortoise Git, which offers broadly the same semantics as you will see in Tortoise SVN. So you can right click on files and see their history. You can right click to push and pull and check in and check out. So that's the nice crutch that you can use. So it visualizes history quite nicely. So you can see the SH1, the commit hash of the latest revision, and you can see where I initially added the file beforehand. Or you can do it on the command line, because obviously it all happened on the command line first. So all Tortoise Git really does is it runs that command line, gets the output, and it passes it into its GUI. So if I type git log, you'll see the history, you'll see my author, the date of the modification, and the commit hash. So cool.
It was late at night.
It was late at night, and it gets later as I go on. I was very busy. So the cool thing about Git, to leverage all this cool full history and local repository magic, is that we can now move forward and backwards in time. And unfortunately, this demo doesn't necessarily highlight it as best it could, but maybe I'll break out to an actual Git console in a while and show you. So what we can do is we can reset to different commit hashes. So we have 2 hashes in our tree that the git log on the previous slide shows, and on this slide. So we've got 8F65 OA90 ... and 052F E0E ... Actually, Git lets you work with shortened versions of those hashes if they're unique. But what I'm going to do is I'm going to git reset hard to 052FE02 ... which is the first commit in the file there. So now if I print the contents of test.txt to the screen, it says hello. And you'll notice that in the change up here, I overrode that text to say hello again. So by moving back in time, it now says hello. So I've not lost any of those changes. All the changes are still in my repository. All I've done is I've moved the pointer of master back to the previous change set. So there are still commits ahead. I'm just not looking at them right now. So it's kind of magic if you have loads of different directories and file structures in there, because Git compresses all its state into the .git file. What you see when you move backwards and forwards in time is files just magically disappear and vanish. And the first time that ever happens, you think, oh my God, have I just lost all my things by resetting hard? You haven't. They're compressed in the .git file, folder even, but you're just seeing the current working state. And we can go forwards again. So I can now, to prove that I haven't lost any of my changes, I can git reset hard to the furthermost hash. And now when I print the contents of test, it says hello again. So that's kind of really super powerful. And the cool thing about that demo is it was all local. We committed, we moved forwards and backwards through history, and we didn't have a single server, we didn't have any access control, we didn't have any logins. And the great thing about Git is actually, whilst it's great for source code, you can kind of use it for loads of other stuff that you do if you just want to track changes and track history. So there's loads of online services that leverage Git for versioning secretly under the hood. Document storage services especially. So how do I share my work? So okay, so I've got a folder and I've got some files in it and I've got some hashes, but I want to share my magic text file that says hello. It's really important work. So generally what you'll have actually done is you'll have cloned from a remote repository that you'll be working on. You know, if you've never used Git before, chances are that's going to be your first exposure to it. Is someone says, there's some code over here when you make a change. So generally you'll end up interacting with a service like GitHub or Stash or TFS with Git mode rather than rubbish Microsoft old TFS mode. So what I'm going to do is I'm going to add a remote. So I created a remote on GitHub. I just made an empty repository. There was nothing in it. And it had the URI, https github.com/davidwhitney/temp.git. So when you create a GitHub repository, it gives you that URL. So by typing git remote add -T for tracking master, so it's going to track the master branch. So you're not going to remember all of these parameters. Don't worry, the manual is really good. You can type help for everything and it will give you all the options. So git remote add -T master origin. Origin is the name of the remote. So I'm saying set this URL as my origin. Now I can git push origin master. And what that says is git push to origin, my master branch. And because I'm going over HTTPS, it asks me to confirm my username and password. Because it's nice, it didn't take a screenshot of me typing my password in. And then you'll see the delta compression. It does it on multiple threads. It writes the objects over the wire. And then it tells you at the end there that what I actually did was I created the new branch master on the remote. Because when I created the remote on GitHub, I didn't make any branches. It was a completely empty, bare repository.
Origin is the logical name of the repository.
So origin is just the name that I typed in. Origin is a convention. Most people use origin as the master source of code, the main source of code. I could have called that, I could have said git remote add t master GitHub and given it that URL, and it would have made just as much sense. But generally, if you only have one remote, origin's quite a good default because people expect it. All that really does is it, in the .git folder, there's a config file and it adds an entry. And you can actually go into the .git folder and you can open the config file and you can manually manipulate the entries in there. It just adds that URL with an alias of origin. It's nothing more than that, and it can be anything you like. So now we pushed our changes to origin. So that's a screenshot of GitHub and my temp repository where you can see my 2 commits went in. So I'm now going to edit the file on GitHub for maximum fun. So GitHub has a built-in editor, so I can just like edit on the text file and type some junk in. And that's exactly what I did. I typed in hello again. I made this change on GitHub. And now you can see in GitHub's view of my history, I've got that extra commit updated on GitHub at the top. And now I'm going to make some local changes just to really, really screw with them. So at the moment, locally, I have 2 commits. And on GitHub, I have 3 commits. So locally, I'm now going to add a new commit. So I'm doing git status, I'm not American. It tells me I'm on master, I've got nothing to commit. I'm going to call git log. You can see my 2 commits. Now I'm going to overwrite the whole file. So echo overwritten into test.txt. So I've just completely nuked the file on my local repository. So if I do git status, it'll show you that I've modified test.txt and I've not added any changes to my staging area. So now I'm going to do git add dot, and then I'm going to do git commit -a-m to say overwritten. So 1 file changed, 1 insertion, 1 deletion. Git status says I'm on master, I've got nothing to commit. And git log shows that I have a 3rd commit in my local repository now. So now I've diverged. So GitHub has 2 common commits and 1 new commit. Locally, I have 2 common commits and 1 new commit. So I do git push origin master, and computer says no. Very, very, very hard. So what happened there was the origin rejected my push because I'm not up to date. So this is kind of synonymous with you checking out code from Subversion. When you check out code, it drags the latest version down. So the way Git approaches this problem is it says merge conflicts are your problem, not mine. I'm not going to let you do something destructive to a repository that I own. I'm going to force you to pull before you can push your changes. And that's basically what that says. Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref, a reference to a remote. You may want to first integrate the remote changes, e.g. git pull before pushing again. See the note about fast forwards. We're not going to see the note about fast forwards. The nice thing about it is that Git told you exactly what to do to fix your problem here. So it kind of does help you out on the way. It's a little bit verbose about it, and sometimes you get critted by a wall of text that you've got to read before it makes any sense, but it will. Okay, great. So Git is smart enough to know we can't automatically push our changes, so it won't let us. I always have merge conflicts, but when I do, I've got no idea what to do. So what I'm going to do is I'm going to git push origin master. And then you see a load of text about network performance. So it's counting the objects that have to come down on the remote. It's unpacking the changes. It's putting them into your local working directory. And it tries to auto-merge. So certain changes can be auto-merged. If I added a new commit with a new file side by side, Gitwood is smart enough to know that actually that's not a conflict. And that's what fast forward pulls do. That's what a fast forward merge is. It's when I add a file, you add a file, we both push, we both pull, but because we've not actually done any changes that affect each other, Git will just get those two SH1s and it'll merge them together automatically and make a new commit at the top. But in this case, I've overwritten the same file, so it's caused a conflict. So what you have to do now is do git status, and it'll tell you exactly what files are unmerged. You then have to resolve the conflict. So Git puts markers in the files with little arrows, and you can use every popular merge tool under the sun to merge them. So P4 merge, I think, I can't remember the one that ships with Tortoise Git. There's lots of graphical merging tools. You can do it on the command line if you like. I personally think people that do it on the command line are masochists. It's a lot easier to use a graphical tool to see all the unmerged files and right-click them and look at a good diff and merge in whatever diff tool you choose. You can configure the diff tool that Git will automatically launch. So you resolve the conflict and you save the file and you add it to the index. So instead of resolving the conflict, I'm actually going to blat it over with some new text. So I'm just going to totally use this instead. And then I'm going to add the file and I'm going to commit it with the message resolved. So Git now recognizes that as me saying, I have resolved you. And it's because it was originally marked as a conflict. I have then changed the file and added it to the index and then committed it. So it says, okay, fine, you know best. I delegated to you. You resolved that conflict. You made the decision, whatever you say. But it is cheating. We can push though now. So let's do it. Git push origin master. And you'll notice now it just took the changes and took them into the repository. So now you'll see the history on GitHub, added test file, changed test file, updated on GitHub, overwritten, and then the resolve commit at the top is a commit that is the resolution, the merge commit of the two changes from both sources. Working with branches. I like that picture. Oops. So making branches in Git is very, very easy, and you'll find that people do it all the time and use them all the time. You can create a new branch from the commit sh1 or sha1 that you're currently at by typing git checkout -b and then any name at all. And what that does is it says, from where I am now, create me a new branch called test. So the cool thing about this, and the fact that everything is just a hash in Git, is you know how we went backwards and forwards in time before? If I want to fork the code at a specific point, I can just reset to that point and then make a new branch from that point. You can also do it without resetting from that point. You can pass it a hash and create a branch based on a specific hash. But basically, git checkout -b name will go from wherever you are to a new branch. And what that means is you now have two completely distinct trees conceptually in your code. So if I switch to test and say echo, I'm on a branch, I then print that out to the screen, I can add it. So there we go, I've just committed git commit -a-m branch test. So I've made a new branch, made a change to my text file and committed it to that branch. And now you can switch back and forth. And this is, again, it's like milliseconds, 5-10 milliseconds rather than big complex operations. So if I do git status, it'll tell me I'm on branch test and I've got a clean working directory. I can cat it to the output and it says I'm on a branch. I can then git checkout master. And what that does is it switches where my current active pointer is to the master branch. So now if I cat out test, it says total using this instead, which is what it originally said on master before I switched. So branches, like everything else in Git, are local. So any new branches that I create, I have to push and publish somewhere before someone can pull them and access the code in them. So feature branches, the takeaway is if you want to experiment in code, pull a repository, make a branch, do whatever you like, and you're completely isolated and safe from ruining anybody else's day. So, okay, I'm happy with the changes in my branch. Let's merge it back into master. So I'm going to, again, just demonstrate that I'm on a branch. So I'm on the test branch, and you'll notice that the branch specification in the command prompt tells you where you are at all times. So I'm now going to git checkout master. So the way you merge in Git is you switch to the place that you want to be merging into. So I'm going to go to master, and then I'm going to say git merge test. So give me all the changes between where master is and where test is, and merge them into master. So now if I cat test.txt, I'm on a branch. And you'll see the branch specification now says master. So that's all it takes to merge changes. And Git will be very, very clever at trying to resolve any conflicts. Obviously, anything that really conflicts between the two branches will go through the same conflict resolution that pulling from a remote will go through. So everything works the same way. You use the same merge tools, you do the same resolution commits, and the pushing and pulling works the same. So where does that leave me? That's the pretty visual diagram that Tortoise Git will render of that operation. And you'll notice that it highlights with little tags where master and test are currently. So it'll put those tags in the visual tree that correlate to the commits, the commit hash. And that's the basics. So the command line tools are a proper system shock, especially if you're used to using graphical tooling. Don't worry, you can cheat. So I'm about to say don't tell anyone, but I first learned Git in 2009. Back in 2009, although I've just told you that the documentation is good now, the documentation was not good, and the support for Windows was not good, and it wasn't fast, and basically things didn't work. Tortoise Git is really actually very good. It's a little bit buggy at times, but if you want to learn Git and you're coming from using something like Tortoise, it's a good place to start. The cool thing about it is it prints out the Git commands it executes when you use it, and that's really, really important. So there's a picture here. So if I can switch to the branch test, and if you look at the window that it generates, it says git.exe checkout test. And that's exactly the command that you would use to perform that operation. So if you want to learn some of the more esoteric commands around Git, Tortoise hides them by, if you hold down Shift and right click, you get a load of other like advanced Git stuff. But when you click any of those menu items, you get something like that pop up and it tells you exactly the command it ran. Basically over about the last 5 or 6 years, by watching those command prompts scroll by me day by day by day, I committed to memory the things that were really important. So the learning curve is notoriously steep. Don't be alarmed. Don't be surprised. Don't be shocked. People say, "Oh, if you can't do anything with command line, you're not a real programmer." Yeah, so great, but assholes on the internet will say lots of things, right? Don't listen to them. The command line is unfriendly, and the learning curve is incredibly steep. Two-phase commits are confusing. Local and remotes are confusing if you're used to a centralized workflow. Don't worry if you feel out of your depth. It's okay. But once you get it, you realize how powerful it is, in that you're completely unshackled from where you are to work, and you can do crazy experimental stuff really, really quickly. And the one final piece of magic in Git is it can basically auto-merge loads and loads of stuff that you used to have to merge in merge tools. I've never been able to quantify quite how it does it. I'm sure there's some incredibly complex computer science reason. But it's managed to successfully merge crazy, like, 4-way octopus mergers of deviation trivially for me and actually get the right answer. So I've generally been very, very impressed with it, and it's fast now, and the tools are good. So where do we go from here? We'll start using it. I'm going to run another session on really advanced stuff. So if you have never heard of Git bisecting or ref logs and all these interesting kind of Git power tools, what that session will go into is how to leverage Git to get yourself out of sticky situations, to find out when bugs were introduced into your code, to work out how you lost code. Say someone deletes a branch that you needed something in. There are ways to rescue all that data from the ether. Git's really powerful, very, very good. I would totally recommend it. But if all those words mean nothing to you, steer clear for the moment and just go and learn Git. And that's my lot for Git 101, and I think I more or less, I stuck to the time. That's unusual. Are there any questions?
I have one.
Yeah.
I guess it's obviously related to testing, but how much can we say it safely reduces the amount of integration testing, or
It
how
does
does
not.
it does not? Okay,
It does
so it's
not.
not.
It's strictly source control.
Okay.
So I suppose the positive impact it will have on testing is that Git is much better at merging diverse code. So longer running branches are still a pain to merge. They're a pain to merge in anything. But put it this way, before I migrated when I first migrated a very large code base to Git, I don't know if this is something that resonates with you, we would have a merge day where we would have a branch and we would sit there and we would go through every commit and we'd go for lunch and we'd come back and we'd go through the rest of them, and then we'd run the unit tests and find out the ones that failed, and then desperately dig through history and work out where we screwed it up and work out if it was a merge error or whether the code was broken. And honestly, I'd spent a day to 2 days doing these things. I don't think I've ever done a merge in Git that's taken me more than an hour. And that's so the 2-day merges take an hour. The couple of hour merges take minutes. And generally the resolution is so good and accurate that it's fast and works and reduces the chance of those errors. Yeah, it'll remove the risk of human errors from long, fatiguing merge activities, but it doesn't do anything to actively stop the introduction of bugs.
Okay, yeah. So you don't, let's say,
People don't screw up as
regression
much.
test the hell out of everything.
Exactly.
Do
Like,
more
So merging in a feature branch for a small feature in Git, I mean, you can regression test everything, but it's probably not worth it because you can be certain that the code files that have changed are only those code files. So if you've got reasonable testing around the software anyway, you can probably say, well, actually, I know for a fact that that's only impacted those 3 files because I can see them, and I know that we've not had any crazy merge shenanigans on the way. Yeah, it's probably fine. The need for regression kind of reduces at that point.
Okay.
Any more for any more? Do the command line things make sense? Just about. Basically, -A means all, and -M means message. That'll probably get you over the initial hump. And then using the man page will get you everywhere else. I mean, the cool thing is, though, once you actually you start using bigger projects, you get to see loads of pretty diagrams about all the branches and merges and how they converge. I'm trying to think if I know of anything that maybe. Let's just click a random thing, because the cool thing about GitHub is it has really great visualizations for branches and merging. So you can see the network. Networks are always fun. And this is a really great way to understand what branches and merging means, because basically any branches can come into any part of the code at any time. You're not necessarily always at the latest. You can merge code earlier in, and then at a later date, bring those commits and merge them at the top. It's quite perverse until you've done it, but you get things that look like this. Just kind of cute. So all these branches here that aren't merged back in are work that's currently not merged with master, not back into the main line. So maybe experimental things. Yeah, very cool. Excellent. And
Can
almost
you
bang
link
on.
that to, sorry, I have a question.
Yeah, no, go.
Can you link that to a Jira story?
So because Git is source control, what you'll be relying on is all the things around it.
Mm-hmm.
So I know here we use Stash. Stash can be linked to a Jira story, therefore commits can be tracked across stories. So Git itself, absolutely not, but because it's all just a hash, those commit hashes are used by Jira, by Confluence, Atlassian do a really good job of tying those commit hashes around everything. But TeamCity builds are builds of a series of commits which can be linked to stories in Jira, and if you install all their integration plugins, all that stuff will work like magic. So you'll click on a story and you'll see all the commits logged against it. Normally the way that people do that is they, by convention, create branches named after the stories, and then the plugins look for branches with those names, and when Stash has those branches pushed up to it, the API integration between all those platforms will work, and it'll key on the patterns of the branch names and match those with Jira card numbers and issue numbers, and then those will be matched up again with TeamCity builds. So that's a very, very cool integration story. It's the good thing about the Atlassian ecosystem is that the plugins do work very well between them. Great. So has anyone in here used Git before? 1, 2, cool. So did you learn anything new from that, or was that all, I presume that's stuff that you've come into contact with so far?
I use Git for Windows, so.
Cool. It works the same.
Yeah.
It does work the same. I think arguably it's still a lot faster on Linux though, but it's now tolerably fast on Windows, so it's fine. But this way, it's faster than Subversion and TFS. Mercurial is probably a little bit faster on Windows today. So Mercurial is another distributed version control system that works broadly in the same way. They just have more or less slightly different terminology. Great, awesome. Well, thanks for coming, and thanks for anyone that's watching this remotely. I hope that was helpful for you guys. And let me work out how I hang up on you. There we go, the big infinite window.